two-part series where today I will be explaining you how the circuitry and mechatronics that you see before you work to make the rocketry alarm system, which I've been making for my task 3 of year 9 STEM. Now, as you can see, when I start this simulation, the LCD screen display is pushed to begin. As we can see, this USB cable is being inserted into the Arduino. Now, normally, this USB cable would be connected to our computer via an adapter, which would be sending it code, which would be telling the LCD screen to display the string push to begin. So that's just a quick summary of how that happens. Next, you can see that we have this 9-volt battery here, and the reason why we have this 9-volt battery is because without this battery, the 3 electrical components on this breadboard wouldn't be able to function, as there wouldn't be enough power, because normally power is drawn from the computer and is sucked into the circuit via the adapter and the USB and sent out to all the electrical components via the Arduino. But there's actually too many electrical components on this breadboard to power them all from just the computer. So we require this 9-volt battery to allow all the electrical components, such as the LED, the piezo, and the LCD, to function properly. Next, as you can see, there's this push button here and another push button here. This first push button is connected to the reset pin on the Arduino via terminal 1B and some hookup wire, and is then connected to ground on the Arduino via terminal 2B and a hookup wire. Now, what this basically does is when I push this push button to make the LCD start the countdown, we can press this button and the countdown restarts. It redisplays push to begin. Now, as I started before, this push button is responsible for starting the actual countdown. It is pretty much the most fundamental part of the code besides, of the circuit, besides the power and the code. Now, as you can see, it's connected to ground via a 220 ohm resistor, the 5-volt pin on the Arduino via a jumper wire, and of course pin 7 on the Arduino via a jumper wire. Now, what this means, the reason why we have this resistor here is to stop the push button from being short-circuited. But the reason why this is connected to pin 7 on the Arduino is because, let's just look into this code here. We can see that we have set button pushed up as a Boolean variable, meaning it's either true or false. And then we have said that button pushed equals digital read 7. So, if this push button is pushed, the Arduino will read pin 7 on the Arduino. And because when the button is pushed, it's sending a signal to pin 7, the Arduino will pick that signal up and then start displaying the countdown on the LCD screen. So we've gone over these 2 push buttons. Actually, we also this jumper wire, which is connected to 5 volts, supplies the push button with power. Well, it doesn't supply it with power. It just gives it some power to regulate, basically, because that's what a switch does. It has to regulate power, and without power, a switch really isn't a switch. Yeah. Next, we have this resistor, and this resistor, and as I said before, basically all these 3 resistors help to stop the components that are in front of them or that they are connected to from short-circuiting. So, for instance, this 220 ohm resistor right here stops the LED and piezo from short-circuiting. Yeah, but I might just talk a bit more about this Arduino. So basically, what this Arduino does is it's receiving power and code from the computer which it's connected up to, and it sends all of this code as inputs out to the electrical components on the breadboard, or it just keeps reading for inputs which these electrical components will make, like this push button, and that'll allow the circuit to basically function properly, because without this Arduino there'd be no power, there'd be no code to allow this circuit to function. Basically, it's sending all the code, a lot of the power, out to these electrical components. That's the main reason why we have this Arduino in the circuit. Next, we can see that we have this LCD screen, and it is quite complex, so I'm going to go over what every single pin on the LCD does. First, we have LED anode over here and LED cathode. Now, LED anode is connected to the 5-volt pin on the Arduino via 220 ohm resistor, and this basically just stops the LCD from frying, as I said before. Whereas we have the ground pin on the Arduino is connected to LED cathode. Basically, the reason that these two pins on the LCD are connected up to these particular pins on the Arduino is because they provide, these two pins on the Arduino provide power to these two pins on the LCD, which powers the backlight on the LCDs. Yeah, on the LCDs, basically just provides power to the LCD's backlight, which, if you're curious, the backlight is the thing behind the LCD's main screen that provides it, that illuminates the string and the actual LCD screen. So without it, there would be no light on the LCD screen. Next, we have digital pin 7, digital pin 6, digital pin 5, and digital pin 4 on the LCD. Now, digital pin 7 is connected to pin 2 on the Arduino. Digital pin 6 is connected to pin 3 on the Arduino. Digital pin 6, I already went over digital pin 6. Digital pin 5 is connected to pin 4 on the Arduino. And digital pin 4 on the LCD is connected to pin 5 on the Arduino. And the reason that these pins are configured in such a way is because digital pins 0 through all the way through 7 are data pins. So basically, all of these pins on the Arduino are sending important data that the LCD needs to function to these pins on the LCD. So you can think of these pins as basically a highway that is giving important data to the LCD, allowing it to function. But the main reason that these particular pins are connected up to basically the reason that digital pin 4 is connected up to digital pin 5 specifically is because when I was searching for open source code to help me with building this circuit, building this solution to the problem which I was trying to solve, I found that this was the most common configuration for the digital pins. So it would basically give me the most options when I was building it. Now let's move over to these three pins: enable, read and write, and register select. Now the enable pin is connected to pin 11 on the Arduino. And what the enable pin does is it allows the LCD to display strings on its main screen. And this is really important because without the enable pin, we wouldn't be seeing push to begin here. We would just be seeing blank columns on the LCD screen. Next, we have the read and write pin on the Arduino, which is connected to ground. Oh, wait, no, the read and write pin on the LCD, which is connected to the ground pin on the Arduino via a jumper wire. And basically, the read and write pin tells the LCD if it is being sent inputs or outputs. So it basically knows which type of data it's being sent. Whereas the RS or register select pin is on the LCD is connected to pin 12 on the Arduino. And this basically tells the LCD whether it is being sent data or not. So these, as you can see, register select and RW work hand in hand, because first, register select has to tell the LCD whether it is being sent data or not in the first place. Then read and write pin tells the LCD if it is being sent inputs or outputs. So slowly, these pins allow the LCD to understand what type, if it is being sent data and what type of data is being sent, so it can comprehend what to do with said data. And then, of course, you got enable, which basically just allows the data to be displayed. Now, next we have the VO or contrast pin, which is connected to the 5-volt pin on the Arduino and the ground pin on the Arduino via a potentiometer. And the main reason that it's connected to a potentiometer is because the contrast pin on the Arduino is supposed to change the brightness of the backlight, which I talked about before, and the potentiometer can actually change the brightness of the backlight by limiting the flow of electrons that the backlight has access to. As you can see, that's what I just did. I turned the potentiometer's dial down, and it's a lot dimmer. Now I'm going to turn it up, and it's a lot brighter. So as you can see, it's restricting and giving more access to for electrons to the backlight to either dim it or make it brighter. Then after that, we got the VCC pin or the power pin on the LCD, which is connected to 5 volts on the Arduino via a jumper wire, and the ground pin on the LCD, which is connected to the ground pin, of course, on the LCD, on the Arduino. And basically, this just provides the entire LCD with power. Now, I think I should have gone over everything now. I've talked about these two push buttons, this external power source. Wait, no, I haven't gone over what this piezo and the LED do. Basically, this LED and this piezo really allow this alarm system to act as a functional alarm system. So, I'll just show you what happens when we press this button. As you can see, there's a countdown, which you should have seen before. But after this countdown happens, which you'll see in a minute, the LED and piezo turn on, and the LED makes basically lights up, while the piezo makes a buzzing sound, which you can obviously hear now. Now, I'll just reset that quickly. As we can see, the LED and the piezo basically act as the sort of backbone of the actual alarm system. The LCD screen does this as well, but it's more of a visual alarm, whereas the piezo and the LED are much more obvious. So we've gone over what this potentiometer does, what this USB cable does, how the circuit gets power, how the circuit gets code, what these resistors do. Basically, they just stop all the electrical components from short-circuiting. And finally, we're going to talk about why we have these hookup wires being connected to the LCD. Now, you may be thinking that we could just use jumper wires, which on Tinkercad, yes, we can do. But in real life, if you're using jumper wires to try and connect let's say the reset pin up to terminal 1B on the reset push button, that won't work. You need these hookup wires to hook up into the these pins, so that they can receive electrical signals. So I hope I've been able to adequately go over how this circuit is able to work and act as a proper alarm system. I hope that you'll give me some lenience and hopefully give me full marks for this section. Thank you.